I read chapter 3 of Baby Rudin, so that's where I'm at so far in reading this book. I will briefly show my notes. This is a complete notebook now. Let me see if I can zoom out. Yeah, okay, I'm zoomed out. So this is a complete notebook and my 19th notebook of notes. And I did keep it a track of where I am with the problems, pages. So I'm at 68 versus 306 notes, which is 22%. So I want to get to a higher number. And then, yeah, so this is the full book now. I'm going to start a new notebook. I've read way more than I should have before I started doing problems, but I have started doing problems, and so that's good. And I think I'm going to do a lot more work in the Mendelssohn book before I attack the chapter 1 problems in Rudin, but I want to get to those. Those are kind of like the harder problems, and I want to get to them. So yeah, I read chapter 3, and it was a fairly straightforward read. Of course, doing diagrams as always, but there were a couple of proofs where I was like, I guess I'm going to have to read more about this elsewhere, which happens sometimes. Most of the material is material that I've seen that I remember from Wade, but some of it wasn't, which is the reason why I'm reading this book. I did look up in ChatGPT about complete metric spaces, and ChatGPT gave me some very good examples. And so it also gave me examples of metric spaces that are not complete. That was very interesting. P-adic numbers, I remember that from number theory. The rationals with the Euclidean metric, so it's got to do with the set and then the metric that is associated with it. Yep. Limits. Some good examples for series, which of course Rudin always excels at. I was trying to understand one of his proofs, but I know from recent reading that I've done elsewhere that now I can go back to this particular proof, and it is explained in Bardo and Sherbert. So the way Rudin wrote it, he got me all confused, but now I understand it. Now I understand why you use the binary, the binomial theorem, and then you only match 1 plus x sub n square, and you don't match n x sub n to get a less than or equal to relationship. Yeah, so now I know, but I did get, when I first read it, I was like, what? Where's this coming from? And I was doing all this kind of work. I always use these brackets for what is my own work versus what I'm reading in the book, so that I can tell later what came from the book and what didn't. Comparison test, things that I've seen before, so that's good. And then Rudin had a proof that E was irrational, and I was like, what? I don't get it. So I have to come back to this proof. The way Rudin did it, he kind of threw me for a spin, but I did dig up a handout from Wikipedia, and the type of proof that he used is similar to a proof that is done in Wikipedia, where they do use terms in a sequence. And then, but in this case, they subtract one from the other. And in the case of Rudin, he just compares them. So I gotta get back to this. And then in the case of series that show how the infimum of the comparison test is the smallest value, and the supremum of the comparison test is the largest value in the limit as n goes to infinity in the series, the convergent terms. And then the infimum of the square root to the n of a sub n, they're in the middle. Now, Rudin has this great example that shows that with numbers. I couldn't really do it completely. I tried, and I could see where you can pick one term over the other, but I only ended up getting this value, the 1/2 3 over 2 to the n, and I got a 1/2 and 2 over 3 to the n here, and Rudin doesn't have a 1/2, and I don't know how he got these. So I got to come back to that as well. So there were a few hidden gems that are very Rudin-like, missing many steps, even though you'll find them nowhere else. So that's why Rudin gets read. But yeah, I already have a couple of things that I wrote down that I know I'm going to have to come back to. Also, the reordering proof. Where is it? Let me see. Yeah, the rearrangements proof. I have to come back to this. Also, I want to sit down and go through an actual example with numbers, and then pick numbers for all of these subseries, all these subsequences, because I really didn't understand it well. Actually, I didn't understand it. So this is another comeback, the rearrangements proof. And so that's chapter 3, and the reason why I read Rudin first for the content, and then I go back, then I go and read in other books, is because often Rudin is either the one that has content that nobody else does, which is great, and or things that I just don't understand when I read Rudin, and I need somebody else, like teach it to me like I'm a baby, which I am.